Hello, this is CET 3383, System Analysis. Well, in today's lecture, we're going to discuss the tools of structured analysis. As I mentioned before, briefly we discussed in previous lectures regarding these tools that we use to perform the analysis phase of the software development. These are data flow diagram, data dictionary, English narrative, structured English, decision tree, pre-post condition, and flowcharts. Of course, as you remember, we also discussed a context diagram in last class, and we said that is also a tool. But we discussed enough of that one, so we are just going to talk to you about some of these and in today's lecture. And continuing with those tools, entity relationship diagram, state transition diagram, transition and action table. Data flow diagram. First, in the part one, I just want to mention what is the process, what's the tool, what's going on, and then we'll go to the follow-up. The process here is to model systems function. That's what we are trying to do with data flow diagram. We want to model systems functions, the tasks the system is going to perform, all right? And the tool is the diagram, data flow diagram that we're going to use. Here is one example, data flow diagram. The source, an external source, provides a data flow to process number 2 and also provides a data flow to process number 1. Process number 1 takes that one as an input and provides 2 output, one to writes a data store, for example, data store meaning, for example, a database, and also provides some information to an external entity. But this process, once it gets the information from this source, also gets some data from the data flow diagram. Notice that. Okay, this is some sort of what we call them. It's a data flow diagram. This is how the data flow diagram it looks in general. But we're going to practice this clearly, and you're going to get to know very well. What are the components of a data flow diagram? Processes, which are those bubbles. Data stores, where we store the data, databases. Flows, those arrows, and the terminals, source and the sink. Source meaning the external or the entity that provides the input, and the sink means the entity that receives the output. Data dictionary. What is data dictionary? What's the process? To show the details of what information is transformed. Detailed definition of data flow. And tools is the data dictionary. And we will discuss data dictionary in detail, and you're going to see how we are going to identify the data, how we are going to show the data. Basically, here we define the format, the meaning, and everything. Here's an example of a data dictionary. For example, say key phone number. This is a variable. We are saying it is a local extension. This means or, outside number, or 0. Local extension, in this case it is 2001 or 2002 all the way to 2999, or conference set, meaning it's a conference call. Outside number, for example, we say you have to dial 9 plus, when you have groupings, then you put them in a bracket, and I will explain these a little later completely. Local number plus long distance number. What's the local number? It's the access number. If you say access number, now I have to define it. What's the access number, right? Long distance number, it is a 1 plus area code plus access number. Conference set means if you put them in the curly braces like this, that means it's the minimum of 2, maximum of 6 digits. It's a number plus local extension and another number. Area code. It's a minimum of 3 digits, a maximum of 3 digits, all right? And it's in numbers between 1 and 9. Let's say 506, all right? 506, 407, 386, all the area codes. There are 3 digits. All digits are between 1 and 9, right? It's minimum of 3, maximum of 3. Access number, the phone number. 7 digits, minimum, maximum 7 digits. In US, that's the case. And the digits are between 1 and 9. Digit 0. If you want to define them in English, you put asterisk, numeral 0, asterisk. This is how we define all these. Data dictionary is going to be like this. For everything that we use, for every variable name. In programming, we sometimes use those X, Y, A, B, C as a variable, and we had to know what's the A, or we had to know what's B, what's the X. In real world, we don't use those kind of variables. We use a name that makes absolutely sense. But someone looking at it should be able to understand at least what is it about. Okay, this is data dictionary. And we're going to talk about all of those symbols, and we're going to define every one of them. So you will know everything regarding that. What's the process specification? A process is to show the detail of how the information is transformed. Meaning this is about those bubbles, those circles that are representing our processes or functions, subroutines, tasks, all right? How are we going to discuss detail of those information in a software development document? Well, we could use English narratives, we could use structured English, we could use decision tree, decision table, pre-post condition, flowcharts, all kinds of stuff we could do. And I'm going to show you how later on, how I am expecting you guys to do. Very simple, very easy, that explains exactly what's going on in the process. The way I do it, I say what's the input to this process, what are the output of this process, then note, explain briefly in 1 or 2 sentences or 3 sentences what exactly goes on, what processes goes on inside this process, what takes place within this process. That's how I do it. So I put inputs, process name, first put the name, process number, then inputs, outputs, and then note, colon, explain. For example, save order number and date on journal, or fetch customer record of customer number if found, add order total to customer total, set customer activity date to today's date, otherwise invalid customer number, save customer order on error log. These are the kind of the names, the statements, the explanation we put for those. Entity relationship diagram. That is really used for designing systems like database, that you have to establish relationship between the tables and between the data, so you know how to store them and how to find them later on. And this is, so the process is to represent a model or to represent the relationships among the stored data. Tool, entity relationship diagram. We'll do some examples. For example, entity relationship diagram. Department, employees. These are projects, and you notice that the entities are department, projects, employees. Right? Employees work in a department. Employees also work in a project. One of the employees is the head of the department. You see, the head of the department has to be, first of all, the employee of that company or organization, and also it has to be head of something, right? It's the head of the department. So we establish this kind of relationship. So the users, the people that are going to maintain the system later on, or even the designers and the programmers should understand the relationship of the data that they're going to relate later on, design it and code it, implement it. State transition diagram, also we named it. And a state transition diagram, the process is to model the time-dependent behavior of a system. And as an example, if you remember, I mentioned systems for a car, or systems that turn on the lights at certain time and turn it off, dim it up, dim it down, and turn on that hall's lights, turn on the air conditioning, open the door automatically by 8 a.m., and that kind of processes, softwares that runs the whole security of the building, for example. That kind of stuff, we usually, in order to make it understandable, we use the state transition diagrams. What are the tools? We create a state transition diagram, and also we establish or write a transition and action tables, meaning what caused and what action, what caused an action. Or we can look at them, what external event may cause certain response from the system, and what kind of response we expect from any kinds of events. So it is something that we're going to practice that one, that we have to look at them and make us understand how to, again, design and establish that kind of system. Okay, I believe this is how much for this lecture I want to do, and in part 2, which I'm going to do it in a second, I'm going to discuss some other parts.